Hello, John Talley here with Partzilla.com, and sitting before you is the engine out of our 2016 Yamaha YXZ1000R. Now, what are we going to do to it? Well, we're about to pull this thing all the way down, drop its compression, and then we're going to end up putting a turbo kit on it. But before we can do that, there's a lot of modifications that we need to go through. Now, I've already got the parts laid out, so let's step over and look at what I've chosen to get this thing set up for this build. Well, all right, guys, here you go. I've chosen to go with a low compression setup from Wiseco, forged pistons. Can't go wrong with a company like that. But we're also going to have to change out the connector rods. The ones that are in the 2016 model, they're just not up to the task. They're a little bit too thin through here, so we're going to update to the ones out of a 2019 through, I believe, 21. Now, added to that, you're going to need a top-end gasket set as well as this individual gasket that goes on the oil pan itself. Now, there's one part that you're going to need to get that I feel strongly, especially if you're going to do a turbo build, and that is a stud kit. And the one I've chosen to go with is from ARP. They're the leader in the business. That's just all there is to it. So go find a reliable supplier and order yours. Otherwise, I don't think a full turbo application is going to survive just having the stock studs in there. Now, granted, this is the beginning of the tip of the iceberg. There are other pieces that I don't know about yet, and I won't know which parts to order until I break it down. One of the most important, your connector rod bearings as well as the main bearings for the crankshaft itself. Those will be determined by markings on the crankshaft and the block, so to speak, and we won't know until we actually pull it apart. But this will get us started, and I'm sure I'll be adding parts along the way. But if you're doing your build, this is what you need to order that you will absolutely have to have, and other parts will be determined as we go through the build. So if you're ready, let's go dive into this. So let's get going. We're going to start off by just removing all the different venting and the intake, any of the wiring that's still attached to it, get that out of the way. Let's go ahead and get our throttle bodies off. Best way to attack that is to take them off by leaving the adapters in place and just pulling them out of the adapters. You will expect a fair amount of resistance here because there's a lip that's more or less locking them in. There we go. There's that lip I was talking about. It takes a fair amount of muscle. Just be smooth about it so you don't damage anything. Next, let's get our cooling lines removed, and we'll take that off as an assembly as well. Now, when I go to do the build, I'm going to go ahead and replace all these lines because, let's face it, I mean, they're coming up on 7 years old, and we're going to be asking a lot out of this engine. So we want to make sure that everything else is going to be up to the task of the additional horsepower that this machine is going to produce. Now, when you're doing this, make sure that it's bottomed all the way into each one of these bolts, because if there's any dirt or anything, and you don't get it bottomed out all the way, then you run the risk of stripping it, and then you're going to be in for a battle. Because as you can see, I'm having to put a fair amount of torque on this to get them removed. Probably getting ready to bleed onto the table. Even though the oil has been drained out of it, I'm sure there's a few passageways that still have some residual sitting in there. Just be ready for it. The most important tool that you can have when you're pulling an engine down, a mark saw and Ziploc bags. Because it's all fun in the games when you're pulling it down, but in a couple of weeks when you're going to put it back together, are you going to remember exactly which bolts go where? I can't, so why would I do that to myself? Get out the bags, start writing it down, do it by section. That way it'll make it a whole lot easier to put back together. Now, this part of it is actually an oil cooler. So you've got your coolant that is going through the head and of course coming back out, but it's also getting pumped through here, which is a heat exchanger, which helps cool the oil down as well. Alright, let's get some of this electrical out of the way. And then we'll start working our way down. Alright, let's go ahead and get our coils out. Alright, let's go ahead and pull our inspection covers. We'll go ahead and pull our valve cover. That way we can bring it around to top dead center. Now, is this really super necessary since we're pulling it all the way down? In my opinion, yes, because we're going to be removing the camshaft caps, and if they're in an awkward position, you potentially could crack one of the camshafts because these things are extremely hard, but that also makes them very brittle. And I don't want to start out my day by breaking a camshaft. I like what I see there, and I don't see any signs of burnt oil. The lobes that I'm looking at look to be in good shape. So far so good. Cautiously optimistic. Ooh, boy, that chain is loose. Yep, that should be it there. TDC mark here, and then you can see the marks here, here, and here. Wow. Now ask me if I'm going to install a manual chain tensioner. The answer is yes. Wow. Next, let's get our tensioner removed. Can't wait to see what kind of shape this thing's in, because I don't like anything of what I just saw. That's scary. Yeah, I know we didn't have the engine running, and you've got hydraulic pressure from the oil that really keeps tension on this thing, but I'm just not going to trust it. We're going to go back with a manual one. I had ordered a new one, but I think I'm going to get a manual one instead. That way, I'm sure. Yeah, ask me if I'm replacing the chain too. The answer would be yes. All right, let's get some caps off. A few turns at a time, so you can see the springs pushing up against it. Now, the difference in between your intake and your exhaust cams, you can see it right here. This is a much larger section than what's on the exhaust. There's one bolt goes right through here, and I'm not really sure what it does, other than you wouldn't be able to remove the head with it there. I don't have an answer for that. I mean, does this really need to be supported there? I don't know. And no, I don't care that the chain's about to fall down into the engine because I'm taking it apart anyway. All right, guys, we're getting ready to remove the head bolts, and we've already got the first two out of the way. And I've got the other ones numbered 3 through 10, and this is for disassembly, and we're going to go through that sequence at about a half a turn per bolt until it's released pressure on the head evenly. That's going to reduce the chances that we warp it. And yes, they will have a fair amount of torque on them. I think that's everybody. Let's go back around. All right, looking good. A little side note, we will not be using these same bolts or even new bolts of the same type, because we're going to go with ARP studs. A really nice set, by the way. All right, let's see if she wants to lift off now. be careful as you do this, because if you tip it over, the shims are going to fall out. All right, looking good so far. I don't see any scoring. I can still see a little bit of the crosshatch. So I think we're going to be good to go with this one. All right, let's keep going. Let's go ahead and get off our end cover, which of course has the stator under it. And then we'll spin the engine around and start working on the output shaft, if you want to call it that. At that point, we can turn the engine upside down, split the cases, start getting those pistons out, or the connector rods out. Well, it looks like they're all the same, except for just that one that was holding the pipe in. And the top two have washers on them. Those little arrows, those are the telltales if you're supposed to have a washer or not. I guess there's oil on the other side, hence why they're having to put a washer. There you go. But keep in mind, you got the magnet from the rotor trying to keep it in there, so don't let it pinch your fingers. There we go. All right. Started a reduction gear. Let's go ahead and see about taking off our rotor. Let's see if that holder is going to be strong enough to do this. Not yet. I decided not to play nice anymore. Great for taking apart. Don't use this to assemble it, please. All right, guys, we're using a basic flywheel puller. Now, this one's a little bit different because the bolts have to be extra long to get in there. And of course, Yamaha makes a specific one, and we'd be glad to sell it to you, but it's kind of pricey. So I did a bit of a workaround with a unit that I already had. All right, and I don't know that these bolts are going to be strong enough to do this, but I guess we're about to find out, huh? Let's see if we can get it to pop loose. Hopefully we can put a fair amount of pressure on this and then shock it off of there. There you go. Amazing what a little tap of a hammer will do. I do want to warn you, whatever puller that you do use, make sure that you don't damage the end of the crankshaft. This one had an adapter to keep that from happening. All right, guys, we've got that side taken care of. Let's spin it around and address the output shaft, get it out of the way. Then we're going to turn it upside down and split the cases. Let's get these retaining bolts off. This little impact should be enough to deal with it. Yeah. We should be able to just remove that inner bolt. It's a 17 millimeter. Let's go ahead and see if we can get it to break it loose. Yeah, not that bad. Not bad at all. Loosen the flywheel bolts. You'd think this would come off as an assembly, but apparently not. They're calling this the flywheel. I think there's more to the story on the inside, so that's where that's going to stop for right now. We're going to go and remove the timing chain guides. Okay, let's turn it upside down and probably make a big mess. Not too bad. I forgot about the starter. Let's go ahead and get it off. There we go. All right, let's go ahead and remove all these 5 millimeter head Allens to get the oil pan off. Now there's no order for these, but when we go to separate the crankcase, there's a very specific order that the bolts have to be loosened half a turn at a time. We'll cover that in a second. Okay, let's see if we can get her to pry loose carefully. Okay, good. Whew, starting to worry me. It's like I'm opening up a crypt. There you go. A little sludgy, but I have seen worse. Not horrible. All right. Let's go ahead and start getting our oil pump out of the way. That should get it. This is the oil pump. This entire thing is your oil pump. And it's making a big old mess. Alright guys, before we break those mains, which are the most critical, we need to go ahead and get this end section off. Then we'll release the main, what I would call cap bolts, if I were building a V8. Guess we're going to see how this is put together now. Very odd arrangement. Let's see. Getting close. Right at that O-ring. You just have to be really patient doing this, guys. There we go. All right, now we got something. Almost looks like it's gotten wet or rusted in there. That's not a good thing. I think we're going to be replacing that bearing. Yeah. If you can hear that, it shouldn't sound like that. So yeah, I think we're going to have to do something about that. I don't know how water would have gotten in there, but my theory is that there's, of course, a seal further in here, and water must have gotten past it into that bearing and made it rust. Something new every day. Well, wouldn't you hate to be at the dealership? Well, we need to replace your output shaft seal. The engine's got to come out to do it, but yeah. That one seal that's on the inside of here is probably 10, 15 bucks, and it'd cost you $500 to get to it. That's always a little Easter egg when you're pulling apart an engine. Always. All right, guys, if you're like me, you're going to have to pause the tape, look at this drawing that we're showing you with all the numbers, and we're going to take them out 1/2 turn at a time, going from 24 down to 1. So you'll need a 10 and a 12. So let's go. With number 24 first. 23 way down here, 22, you get the idea. And actually a 1/2 turn, these are going to be loose, so you're basically just breaking them loose. The ones that really count are these 8 down the middle. And these we need to replace. Especially that one. All right, guys, we've got the timing chain out of the way. Now, I think we're ready to split the crankcase open carefully. Let's see if she's ready to release. I don't want to pry on that very hard. There we go. Oh yeah, it's game over. Beautiful. All right, now we are using different connecting rods. So normally I would number them 1, 2, 3, but that really isn't going to matter. I mean, we can just so we can keep up with them just for the heck of it, but it will not matter because we're going to have to size bearings and plastic gauge them and all that fun stuff to make sure that she's going to spin for a long time to come. Not too bad a wear. But that's the problem. These aren't strong enough. But we will want to save our connecting rod bolts, our old ones, because when we go to check the clearance for plastic gauge, we want to reuse these to do that because they're one-time use. Once we get it where we want it, then we'll use the new bolts that came with the connecting rods. So keep that in mind. A lot of cleaning going to have to happen. Okay, let's lift her out. Oh yeah, looking good. Not that it matters, but we're going to number them just in case I need to reference anything. I'll number these main shells. All right, guys, with that crankshaft out of the way, we want to go ahead and take off our counterbalance, and it's just held in by this one bolt, but you need to bend this little tab back before we can remove it. And to keep it from rotating, we're just going to use a small piece of wood to go right here and then buzz it off. Piece of cake. And once we get that done, then we'll head over to the water pump side, get it removed, and that'll pretty much complete, breaking down the block. We'll leave that in for the time being. Let's go ahead and rotate it over. We can probably leave those 2 Phillips in place and remove the hexes, and then I bet you that will come off as a unit. Let's see. I kind of doubt it. I'm betting it needs to come off so I can get to the actual shaft that's going to be coming through it. I could be right. Yep. All right, guys, this is what we're after. Another tab, just like on the other end. All right, that piece of wood wasn't going to fit in there, so I just used a pair of pliers with a cushioned handle to keep it from damaging it. All this alignment will be really important when we go to put it back together. There we go. Yep, we're going to be looking at the exploded diagrams when it comes time to put this back together. Alright. There we go. That's a lot going on for just a counterbalancer. How many pieces was that, like 10? So we've got a couple of bearings to get out. To get that guy out of there, we're going to use a blind bearing puller, and we're using one that's part of a kit from Motion Pro. Really nice setup. I don't know another way to really do this except to use this particular tool. And we are going to this much extreme because I am going to end up sending this over to the machine shop. And I don't know about yours, but mine, they prefer to have everything completely removed from the block. That way, they're not responsible for all of your dowels that you think they lost and they thought you never brought in to begin with. So it just makes it simpler to bring it in completely clean. That way they can do the work that they need to do and get it back to you even quicker. So let's get this one pulled out. Cool little tool. All right, guys, if it's rubber, it doesn't need to go into an acid bath. it gets screwed, glued, and tattooed. Okay, tell you what, while I'm staring at it, let's get this cooling line removed, because it's going to have an O-ring on the back side of it. I feel confident. Yep. Well, looks like we got one bearing left. And that should do it for the top half of the block anyway, / cylinder. I think we'll be using our blind bearing kit again. Right tools can make everything possible. So I usually don't pull my dowels on either end of a case, but I do on the bottom and on the top, and I think there's one more left on the top. Now, most of the time I replace the dowels when I'm going through, because invariably you'll end up damaging, but what if you can't get a replacement? I have a new tool, a dowel pin puller set. Motion Pro makes everything. Let's see if she's going to cooperate. That one, it was corroded in there. Now I'm still going to replace this one, but that would have been tough to get out any other way. Well, all right, guys, there you go. She's all broken down, but now the work's really going to get started. As you go through the process of pulling down an engine, there's a few telltale signs that may say, well, you need to slow down a little bit, take it to a qualified machine shop, and have them make sure before you go and build your engine. So what I want to do right now is walk you through some of the details that I saw as I was pulling this apart that made me decide to stop the build, load everything up, and then take it over to the machine shop. All right, first and foremost, when you're looking at the camshafts on this particular engine, they don't look horrible, but you can still feel a little bit of a groove. Now, is that too much to reuse? I don't think so, but when I go to put it back together, I want that surface as smooth as it can be, so where it'll last the longest. So we're actually going to take the camshafts and have them use an emery cloth just to get those polished back up. Now, he won't actually be machining anything. We just want the surface to be clean and try to get rid of as many of these little imperfections that we can see and feel with our fingernail, just barely. Another area that you want to take notice of are your caps that are actually holding the camshafts in place. Now, granted, you've got two really very dissimilar metals here. Your camshaft is made out of very hard, brittle material, and your caps are typically made out of aluminum. So you need to make sure that they haven't been gouged. Now, these may look a little bit worn, but my finger is telling a different story. So I think they're going to be good to go once we get the cams just repolished on the journals themselves. Now, the other big area of concern is something that you won't be able to see with the naked eye. But when you've got an aluminum head, as we do, and an aluminum block, sometimes those can warp when you're putting them together and when you're taking them apart. Even though you pulled everything apart in the right order as far as releasing the head, sometimes they can get just a little bit out of spec, so to speak. Now, can you just lay this thing down on a flat surface and see it? No. That's when it's really important to take it to a machine shop to where they can put it on an extremely flat surface, and then they'll be able to see and use their feeler gauges to see if there's any warpage of the head and if it needs to be resurfaced. Plus, let's be honest, there's nothing quite as sexy as picking up a head that's been resurfaced and cleaned from the machine shop. It's just the way to go. Now, could I have put all this together as it is? Yeah, and it might have been okay. If you're like me, you don't want to go through this much time and expense and not know and be certain that those surfaces are going to mate back together and seal up as they should. The other thing that you can't see with the valve still in here is one of them could be bent. I've pulled apart machines that everything looked fine. We put them on the table and rolled them, and you could actually see the heads move back and forth. So just because they're sitting in there flush at the moment doesn't mean they're completely straight. So another thing that you don't want to just glance and gloss over is taking it apart and taking a look at the valves. And once again, the machine shop is going to be the best place to do that. Now, working our way down to the crankshaft. Now granted, your fingernail and your fingers and your eyes, they can see a lot, but they may not pick up on a crank that has been twisted a little bit. They're not going to pick up on any type of abnormal wear, in other words, turning one of your journals into an egg. Whereas when they put this in a lathe and actually put a dial indicator on it and rotate it, they're going to be able to see if there's anything out of spec before you go put it back together. Once again, that's not the type of equipment that the average person or even a professional as myself has at their disposal, and that's why it's important to find a good machine shop to take care of such things and measure them to make sure that they're going to be in spec. Last but not least, the block. And as the head, it's the same game. They're both made out of aluminum, and you know as well as I do that they can warp if they're not assembled correctly, disassembled correctly, or just time and possibly, well, this machine may have been overheated and I don't know that. And there may be some imperfections or not a flat surface to deal with. So once again, do you go through all this trouble and not know that this surface is truly square and flat and ready to go back together? Well, I can't tell in this shop. Hence why I'm going to take it to all of this to the machine shop and let a pro handle it. I don't know about you, but I don't want to go through this much time and expense and not be absolutely certain that everything's going to mate back together and then stay together for a long time. Now, all these things that I've talked about your machinist measuring and looking at and maybe massaging a little bit, yes, there is a cost with that. But try to factor in what your cost is going to be if this is not all correct and it all blows apart and you have to start over. That initial charge that he's going to send you a bill for will be minuscule compared to all the new parts that you're going to have to buy to rebuild an engine. So you see where I stand on this. There's a lot of things that you can see, but there's also a lot of things that you can't see. And if you're going into an engine to this level, don't cut the corners. Go ahead and have the machine work done, looked at by a professional that has the tools necessary to do the measurements to make sure it's all going to go back together as it should. All right, guys, that's going to do it for disassembly. Well, what's going to happen next is go ahead and get the connector rods attached to the pistons. Now, to do that, you want to have the orientation of the connecting rod with the Y facing to your right and your arrow on your piston facing up. So this is where we're going to end up. Arrow up and the Y on each connecting rod to my right. And this is going to be just a typical installation of a circlip. You want to make sure that the ends are not in this little cutout. I usually put them about 3 o'clock, just above it, and then we'll walk it in with our fingernails. And it's important as you're doing this not to let it scratch. All right, and all we're doing here is just using the screwdriver to get that last little bit in there. Okay, next, let's get some assembly lube where the wrist pin's going to be going. Let's get our wrist pin started. Our arrow is facing up, the Y is to our right. In she goes. Now let's get on our second circlip. There we go. Now I usually put a screwdriver or a pick and just shift it back and forth a couple of times just to make sure it's seated all the way in. Let's go back and do that to the other side. Good to go. Now going forward, this is going to be piston number 1, and I'm going to label the other ones as well, because when I go back and check the gap, that's going to be important, but more than that, the bearing sizes, which I'll show you how to do that later. 1 down, 2 more to go. Same process. Let's get this table shifted out of the way and start checking our ring gap. But before you start any assembly, you need to go through yourself and make sure that there's no residual left on any of the surfaces. So let's do a little bit more cleaning before we start checking the ring gap. Now typically I just use brake cleaner, but Yamaha has a great product, especially when it comes to cleaning the internals. It's actually a PPC precision parts cleaner. It's a little bit step above just a regular brake cleaner. So we're getting ready to gap our rings, but with the YXZ pistons, they run a little bit tighter tolerances than the Yamaha. Now for the Yamaha, you'd be looking at 0.5 millimeters for the top ring and 0.7 millimeters for the second ring. Now, with the YXZ, like I said, they're a little bit tighter tolerances. We're going to be looking at 0.33 millimeters for your top ring and 0.406 millimeters for the second ring. So you want to keep that in mind when you're setting the ring gap, because it is a little bit different compared to the Yamaha. Now, included with each piston, YXZ has a chart that shows you how to calculate the ring gap. Now, for this particular application, we're going to use your bore, convert it over to inches, and then multiply that number times 0.004. So what you ended up with was 3.15 times 0.004, which is 0.0126 inches. You round that up to 0.013, and that translates to 0.33 millimeters. So let's get in our top ring and see if anything needs to be adjusted. We're starting with cylinder number 1, and I typically bring them in a little bit past the wrist, about midway. That should do it. Let's get our 0.33 millimeters and see where we ended up. She just barely goes in there, but it doesn't grab it. So as usual, the YXZ is right on the money. Let's take a look at our second ring. So we're at 0.4. So we are good to go. Now I'm just going to repeat that process for cylinders 2 and 3 just to make sure. I'm not really concerned about exactly what the gap is, because it's not like I can add material, but it's very important that it not be smaller than this. Otherwise, as the rings expand, they don't have room to expand, and then they start damaging your cylinder walls. So that's why ring gap and checking your ring gap is so important. A little too much, okay. A little too little, not okay. Now, if you followed the specification for the Yamaha measurements, you would have to file these down and you'd be making a mistake. So it's important to follow the YXZ recommendations. Next, let's work on ring placement. Now, according to the YXZ manual, they want the top ring in line with the wrist pin here, the second ring 180 degrees on this side, your oil expander here, and then your oil top and bottom here and here. So let's go ahead and start with the oil. Now you want to make sure that your oil expander ring doesn't overlap. So in other words, we want this end to be butted together just like this. Let's go for the bottom. That's on the bottom. Now let's get the oil top. There we go. All right, next let's go to our second ring. But before we put it on, you just want to get a little bit of oil and just lightly wipe it down. That's all it takes. And since your hands are already oily, go ahead and hit that top ring as well. Next, let's go with our second ring. We want to make sure this little end is facing up. Now, if you don't want to damage your fingers like I'm doing, of course, you can use a ring expander tool, make your life a little bit easier. If you're doing it with your fingers like I am, just try not to scratch as you're bringing the edges down. Now let's get our top ring. And you only want to spread it apart the minimum distance. Otherwise, you'll be ordering a new set. Next, let's put a little bit of oil on the piston, especially on the skirt. And for this, I'm going to be using a piston ring compressor from Wiseco. We'll go ahead and oil it up as well. These things work amazingly. All right, that's prepped and ready to go. Let's go ahead and take our end cap off. The bolts are 12 millimeter, and I'll go ahead and tell you, if you get these from Yamaha, they're already going to be torqued, so you'll probably need a vise with a soft grip to hold them still to get them to remove. Now, before we pop this in, let's go ahead and talk about our bearing sizing. Now, on the end of your crankshaft, you're going to have a set of numbers. The first set here, that is your P1, P2, P3. But keep in mind, P1 is this location, that is P2, and then that is P3. Now these other four, those are for your main journals, and we'll talk about that sizing later. So as we've got it laid out here, the numbers on the end were 4, 3, 3, P1, P2, P3. And all you're doing is looking at the end of your connecting rod, you're going to find a number on it. What you're looking for is a number on the side right here. In this case, it's 6. As a matter of fact, all three of mine have the number 6. So all you're doing is taking 6 minus the P1, 2, or 3, then that's going to give you a number. In my case, it's going to be 2, 3, 3 for P1, P2, P3. And that translates into a black, brown, brown. And that's what I have laid out here. So let's put our crankshaft back to the side and get our bearings put in. Make sure our surfaces are clean. There it is. Let's put a little bit of oil on the cylinder walls. Now before we put this in there, let's use a little bit of fuel line just to cover that up so it doesn't even touch the cylinder walls. And our arrow is going to point toward the exhaust, and we're going to pop it in. When you're doing this, make sure you've got the ring compressor all the way down flush. There she goes. One down, 2 more to go. Same process. Everybody's in place. Let's get it turned over, and then we'll address the crankshaft bearings. It's spun around not only this direction, but also this direction. So number 1 is still on my left, going 1, 2, 3, left to right. But before we can place the crankshaft in there, I need to go ahead and place in the bearings for it. And I've also sized those as well, so now is as good a time as any to share with you how to choose yours for your particular application. As we noted earlier, we use these 3 digits to determine our connecting rod bearing size. These over here, those are our main bearing size reference numbers. So ours are 3443. Now the other bit of information that we need is actually stamped on the block itself. The number we're looking for, or numbers we're looking for, are right here. But you'll notice that there's only 1 stamped. And when that happens, that means that all 4 numbers are the same. And in this case, it's 6. So the equation we're going to be using is J1 crankcase minus J1 crankshaft web plus 2. and that's going to give the value that we're looking for. And in our case, J1 is going to be 6 minus 3 plus 2 equals 5, and that translates to a yellow bearing size. J2 and J3 are both the same, and in that case, it's going to be 6 minus 4 plus 2 equals 4, which makes them both green. Now, J4, it is the same as J1, so that's going to be another yellow bearing. Now let's go ahead and wipe it down one more time. I mean, I'm sure this block is clean, but a little bit extra never hurt. So let's go ahead and get those in place. And I'm just going to pop them in. Now when we're measuring with plastic gauge, we want to make sure everything is dry. We will go back later and add the assembly lube. Right now, it needs to be a dry fit. All I'm doing now is just placing a little bit of plastic gauge on the connector rod bearing caps. We'll do it this way then. Gravity was trying to work against me. And our number is going to be facing toward me. Now to get it torqued, we do this in 2 segments. The first, we take it down to 15 foot-pounds, and on the final, we're going to change our units to degrees and take it to 120. Now the safest way to do this is to do them one at a time, because if it rotates as we're going through this procedure, it's game over. So we'll torque down one at a time, remove it, make sure it's right, and then go to the next one. I am going 3, 2, 1, but don't let that bother you. So let's remove it and see what we've got. I can go ahead and tell you, I've yet to build a Yamaha engine, whether it be power sports or marine, where I had to adjust. But hey, you don't know unless you check. Maybe this will be the first time I have to adjust the thickness. All right, we want it in between 13 and 20 thousandths, or rather 0.032 to 0.05 millimeters. And that looks dead in the middle, maybe a tick over 0.038. So as I said, dead on. But we're going to go through the process, check the other two just to make sure, and then we'll go forward. All right guys, I just want to tell you, when you're doing this, take your time, keep everything straight. I don't think you want to have to go back and do this again, do you? Or 2 bearings get swapped. That would not be a good outcome. You can look at the 3 now. P1, P2, P3. They're all equal, so we're good to go. What we need to do now is get this cleaned off, but before we can go any further with the crankshaft, we need to get the counterbalance in place, because without it there, you can't get it in. It has to go in first, so let's go ahead and knock that out. Let's start by getting this bearing down on the end. The trick is here to make sure you drive it in straight. Otherwise, you're going to be here for a while. There she goes. Let's get our gear down in place. All right, so the real trick here is when we're feeding the main shaft through, this gear needs to go on, but it has to be held in place as you're pushing the counterbalance shaft through. Now you'll notice that there's a channel right here, and then you will see a dowel on the shaft itself, and that's where it needs to line up. So let's get our gear in place. There we go. Now on the other end, we have a needle bearing and then a washer that goes on the back side of it. Now we never removed that inner race on this end, so we're good to go. Now on this end, there's a retention plate for the Torx, and my philosophy is if it's on the inside of the engine, for the most part, I'm going to use Loctite, just to be sure. Before we get that gear and counterweight put on the end, we're going to carefully tilt it a little bit and hold it in place and get some assembly lube on this bearing. Right. You'll see that I've marked, see this little flat section? That needs to line up with that dot on the counterbalance. I mean, this has to go in that position. Otherwise, guess what? It's not going to be balancing anything. It'll be out of balance. So that's where we need to end up. Now we're just going to put this end bolt in finger tight. Once we get the other end put together, then we'll come back and torque both of them one at a time. But now it's held in place. Now let's get this other bearing pressed in. And then we have a circlip that holds it in place. We want our sharp edge facing out. All right. Now this one, I've marked it as well. You can see where that it's notched in on that particular one. Now that is going to line up with that dot here. Then here comes the counterbalance. It has a dot here and it's going to line up there. Now you can see it. Now we're just going to put this end bolt in finger tight, and then we'll get the crankshaft back in there and do the final torque on the connecting rod bearings. All right, there is our dot, and I'm just adding a mark to it so it's easier to see in there. And that point on the crankshaft is going to line up with this point, which I've marked on the end of this tooth. Okay, here comes the fun part. Okay, let's get our end caps on and get them torqued. Now before we put the bolts on there, let's put a little bit of oil on the threads and on the base, so that initial 15 foot-pounds of torque is really accurate before we do the angle. Okay, we're good to go. Let's get some torque on those bolts. We're going to go 15 across the board and then go back and do the 120 on each one. So now let's do our angle. 120 is what we're going for on each one. When you're dealing with lower torque values, you want to sneak up on it slowly so you're more accurate. All right, guys and girls, that is feeling really good. Believe it or not, Yamaha says to put a piece of wood somewhere to keep it from turning. And so I think they're talking about just a piece of wood in between here and here. I don't have one, so I'm using a piece of steel bar just wrapped up. And then we're going to torque it down to 25 foot-pounds. There we go. Get the other side. All right. Last but not least, we just need to come back and bend the tabs in to secure the bolt in place. This side might be a little bit tougher to do. I got it. While we're at it, let's go ahead and get this bearing on the end of our crankshaft. Let's go ahead and get some assembly lube in there. This is one that has a indentation here. We just need to line it up with that dowel in the back. Now with that in place, let's go ahead and get our bearings into our lower half of the crankcase. What I need now are the dowels. One there and one there. All right, guys, if you were either replacing your crankshaft and or your block, of course, you'd go through the same sizing procedure that I did earlier, and then you come up with a determination for what bearings go where, and then you would plastic gauge it just to make sure. I did not change the block and we did not change the crankshaft, so it is safe to say that we can go back with the same size bearings that came out of it, and that's what I'm going to do. But I already walked you through the procedure of how to check it on the connector rods. It's the same thing. You just install the case, use your old bolts, because remember those primary ones are one use only. Take a measurement and then you're good to go. I feel confident I can skip over that step. Got my dowels in place, going to lay down a bead of sealant, and then we're going to put this case together. The Yamaha manual calls out Yamaha Bond 1215. I prefer using 3 bond. My weapon of choice is the 1211. Difference in between this and the 1215, 1215 is gray. This is white. So, but it's the same stuff. And you do not need to get carried away with this. Just a thin strip is all that you need to do, because actually putting too much opens up the excess going inside the engine and stopping up your oil passageways. So it's one of those cases where too much of a good thing is bad. Okay, let's close her up. All right, bolts 1 through 8. Get oil on the threads as well as the surface area where the washers come in contact with the head of the bolt. Okay, remember these were the new ones. Now the rest of them we're going to put in, they can be reused. Now we're going to hand start each one of these a couple of turns at least. And then I'm going to use an impact just to seat them. Just to seat them. Very lightly, so I don't wear out my hands just getting these bolts seated. All right, I'm laying these out like they're showing in the list. The silver ones are oil. The black ones get Yamaha Bond. So this is 9, 10, and 12. There's 11. Made one mistake. You can tell that this one was supposed to be on the outside. So this is 15, 19, 20. So now we got 16, 17, 18 are the black ones. 13, 14, 21, 22, 24. And 23 is this one oddball right there. So now all the bolts are in the right place. Now we just need to go through the torque sequence. All right, the way we're going to do this is 1 through 8, you take each one of them down to 11 foot-pounds. Now we're going to go back, loosen them, take them back to 11 foot-pounds, one at a time. Then 1 through 4 is going to go to in between 95 and 100 degrees. And then 5 through 8 goes in between 75 and 80 degrees. Those were the most important ones. But now we just need to finish out the perimeter, get it torqued down in sequence. 9 through 12, we're taking those to 17 foot-pounds. Now the rest of them, 13 through 24, is 8.7 foot-pounds. That's it. The rotation assembly is together and sealed up. So before we get carried away with all the oil pump and the chain and everything else, it is important to go ahead and install your cam chain. Next, do not forget that large dowel. You've got new O-rings that need to go in place. Now here's where you need 3 hands. The trick here is bring up your oil gear and make sure that that 4XV is pointing toward the pump. And we're going to hold that in place as we bring in the oil pump. Make sure you've got your dowels in place. they're in. Now we're going to turn our pump to where it lines up. There we go. Personal preference, a little bit of Loctite on the end of this bolt. Let's bring them all in and seat them, and then we'll get them torqued down. Double check, make sure your O-ring is in its groove where it should be and not protruding out. All right, guys, as we go along, there are going to be several parts that were not on the table, and as we go through this, we'll pop it up on the screen. But if you miss it, you can find it in a link in the description below. 8.7 foot-pounds for all of these. Now let's get this oil gear bolt tightened down. Of course, Yamaha has a holder for it that they call out. But I'm just going to use this one, actually, for my marine side. But whatever you can get in there to hold those, hold the sprockets still, it'll be fine. It's only 11 pounds, so it won't take much. Honestly, probably just could have put a screwdriver right here and done it that way. Or 1/4 inch extension. That would have held it going straight through. You're not talking about a lot of torque here, so whatever you need to do to hold that still. So we're all torqued down. That's good to go. Let's get a couple more dowels and then get our oil pan mounted. Get our gasket in place. Blows my mind how Yamaha uses sealant for just about everything, but not this. Now it is time to close it up. You've got 3 different bolts. Let's get them all bottomed out. And there is a torque sequence, but it's not that complicated. Nothing like the crankcase. All of them are 7.2 foot-pounds, but there is a certain order that Yamaha wants you to go in. And then our oil drain bolt. All right, the sequence is these 2 on the end, the black ones. Number 2 is going to be the oil drain bolt, and then 3, you can do the rest of them. Right, check these. Good to go. While we are here, let's go ahead and put this little retention or guide in. And as usual, they don't require it, but I recommend a little bit of Loctite. And I think we can safely torque this particular thread to 7.2. Next, let's get our chain guides installed. I recommend a little bit of Loctite. Blue Loctite, that is. We're going to take these to 7.2. Now we'll bring in our flywheel. Make sure you've got your washer in place, which we do. Make sure your key is in place. Then just line it up with those teeth and on she goes. Next, we're going to put some oil on both the washer, the bolt, and the threads. And we're going to torque it to 94 foot-pounds once we put a holder on there. This is going to be fun. Let's see what we can get. 55. 84. There she is. Let's go ahead and do the flywheel stator. Yeah, I've got the gasket cleaned off. Takes forever. Hate doing it. Wish there was something easier. There's not. So let's get our gasket in place. Just be careful, because those magnets are going to be pulling in and potentially can pinch your finger. So just be ready for it. Like I said. There we go. And they look to be all the same size, but there's 3 with washers on them, and you've got little arrows to show you which ones those are. Now this clip, or holder, is that one. I just don't see yet what wiring it's going to be holding in place yet. Something else is coming through there. I guess that'll become apparent when we get the intercooler mounted, or the oil cooler mounted, because that's what goes over on this side. I'll take all these to 8.7. Guess we can go ahead and put these in for the time being. Don't forget your O-ring. A little bit of silicone to make life easier. Get our pipe in there. We're finished up on this side. Let's move to the other because there's a bearing we need to replace before we put the output flange on there. Next, that's not going back in like that. That's a little bit ugly. Sounds a little crunchy. So we got to do something about that. Let's get our snap ring off. Excessive how far I'm having to pull it. And then it's a little bit of playing operation because it's twisting. Note to self, get bigger pliers. That was fun. Can't wait to put it back on there. Okay, let's get our seal removed, but take note of where it is pushed into. So this is one of the main seals, and you would be crazy not to replace this if you're this far into the engine, because this one wasn't leaking, but I'm extremely surprised that it wasn't. So it was actually caught. It made it past the seal, but didn't make it past this O-ring. Just strange to have rust that low down in the engine. But we do have to clean this up once we press that other bearing out. Yeah, listen to that. Not good. Yeah. So let's take it over to the press and get it pushed out of there. Voila. Just a matter of getting it cleaned up now. Well, guys, it was a combination of a little bit of wire wheel, then a little bit of brush in the parts washer, and a whole lot of contact cleaner, and then some lapping compound on the back side of emery cloth to clean this up. I'm happy enough with the surface to where I think it's going to reseal and not leak. So let's head over to the press, get that bearing pressed in, and then get it put back together. Now that we've got the bearing pressed in, we're also going to use the press to put in the seal because it has to be set at a particular depth, and that's kind of hard to do with just a regular, hammer using it to push it in. So we're going to use the press to more accurately get it at the correct depth. Just make sure whatever you're using, it goes as close as you can get it to this outside edge without going past it. What we're looking for, other than just eyeballing it, is installed depth of in between 5 and 5.5 millimeters from this upper edge. So let's see what we've got. I went just a little bit over at 5.7. Guess what? I'm going to call that good. Plus, by moving it a little bit further in, it's going to ride differently on the shaft where it was actually worn. So I'm okay with that. Let's get some assembly lube in here. Get some grease around that seal. Tell you what, we're going to add some more on here. Now, get our circlip back down. Last but not least, new O-ring. grease around that edge to make it easier to slide back in. Putting a little bit more grease inside of the crankcase halves as well, because I want that O-ring to go in smooth. All right, guys, let's go in. Make sure that O-ring goes in all the way around. All right, we bottomed out on the crankshaft, so now we need to use our flange mounting bolts to go ahead and pull the housing all the way in. A couple of turns on each one to pull it in evenly. We're going to take those to 8.8 or 9 foot-pounds. Now some oil on our main bolt and on the head of it. We're just going to bottom it out, then put on our flywheel. Then we'll have to hold the flywheel to tighten this bolt. And just be careful when you're getting it to lay flush. It may take a little bit of rocking it back and forth before it finally seats in. Don't force it with the bolts. You want it completely flush before you start tightening those down. All right, guys, we got the flywheel mounted up. All our bolts are in place. Now it's time to get it torqued. We've got our holder in place, and we're about to take that center bolt to 87 foot-pounds. There we go. We'll leave the holder on there and then go back and hit all 6 of these mounting bolts to 27. So we've got this torqued down. Next, let's go ahead and pop on our starter. And I was looking at our threads, and we're going to use a chaser to clean them out because it looks to be a pretty good bit of corrosion. We're going to take care of that before we mount it up. Now, if you do have threads that need to be cleaned, resist the temptation of using just a tap and die set. It can get it done, but it's not the correct way to do it. You'll end up damaging your threads. Now, if you want more information on this product, we have a video that actually addresses what I'm using versus using just a tap and die set and why you should not use a tap and die set to do what I just did. Okay, let's go. I'm going to put some grease around that O-ring to help seal it, but more importantly, make it easier to get in there. And third, if you ever have to remove this again, this is a place where corrosion loves to build up and makes it very difficult to extract. That's it. And these are just 12mm bolts. Now, so make it a little bit easier, I'm going to rotate the engine a little bit to get the water pump on. All right, let's get our old O-rings out. Install our new ones. There we go. What's the chances it's going to stay in place when I bring it over there? I don't know. Well, let's find out. Let's get our blind plug. Make sure you've got your O-ring in place. And I've got a little bit of silicone spray on mine to make it easier to pop in place. Now we can bring over the water pump assembly. Now the trick here is we may have to jog this one way or another to get these teeth to line up. But don't get carried away, because remember, we've got a timing chain that's just kind of hanging out here. We don't want to bind it up and damage it. 4 longs, leave 3 short ones. Taking those to 8.7 foot-pounds. That one tucked up in there, I'd have to take the flywheel off. So guess what? I'm going to use just a regular handle and my internal torque wrench. Now, through the magic of editing, you will hear the beep there. All right, guys, that is going to wrap up at least the bottom end of this engine. We still have to put the oil cooler on this side, but I'm going to save that for a little bit later. We're going to go ahead and cover this up so we can turn our attention to building up the head. Now, we just received it back from the machine shop, and it's been given a clean bill of health. Now, while it was there, I went ahead and had them open up the intake ports, just smooth them out a little bit so it'll be a little bit easier for that turbo to cram in that charged air fuel mixture. So here's what I've decided to go with. You know that I'm a big OEM guy, but on this particular build, I decided to go with parts from Kibblewhite. Now, Kibblewhite is world renowned for their build quality, the endurance, how it's going to fit in here and the longevity, and it's going to put up with the extra stress that we're going to be inducing into this head because this is going to be a forced induction engine. So we went with their Black Diamond series, and they're actually forged stainless steel valves. Now, we paired that with springs, keepers, and seals, all from Kibblewhite. Now, all these are designed to work together. They can withstand the higher temperature and the pressure that we're going to be putting this head under, and it was just a little bit better fit for this particular engine build. Now, the one OEM component we are going to add to this equation is I am going to replace the exhaust valve studs. These were just looking really rough, and that's just not the look I want to have as we're putting all these new components together. I can tell you from personal experience, you do not want to try to remove these studs without heating them up first. Otherwise, chances are you're probably going to either strip it or break it. So go ahead and break out the torch, spend a little time heating them up one by one, and they will come out a lot easier that way. What it's basically doing is just breaking down any corrosion in between these studs and the aluminum head. Because that took almost no effort. Look at that. Big difference. It's a little bit more corroded than the others. I'm still going to put a little bit more heat on that one. I'm worried that the stud's going to break. Yep. Wow. Let's see if that last one's going to come. Yeah. Okay, kids, what's the moral of this story? Heat it up all the way. I'd say go at least a minute and a half, 2 minutes. My theory is on that one is I didn't heat it up quite enough. It was still corroded in there, but I did get it to turn and then it galled it. So guess what else we're going to learn today? How to use time certs, because that's what we're going to use to straighten this out and get us out of this mess once I completely get this stud removed. You know, guys, this is all part of being a mechanic. Sometimes things don't go like the service manual says they're going to go. Every 30-minute job is just one broken bolt away from being a 2-day ordeal. Well, this is what you want it to look like right before we get to put in the time cert itself. Countersunk, nice clean threads going all the way in at the right angle. So now let's get it installed. And if you're curious about the difference in between time certs and helicals, we have a video for that, so go check it out. This is actually stronger than just the stud going into aluminum, and that's been proven. So I have zero concerns about this. But since we seem to be in machinist mode, we're going to go back and use a thread chaser and clean out the rest of these, because obviously there was some corrosion in there to begin with. Now, in a pinch, you can use a tap to do what I'm doing, but it does more damage than just a chaser does. This has many more advantages. So I highly recommend picking up one of these. If you try to do what I'm doing with a tap, you'd have to use a tool to run it in and run it out. Why? Because the very tip is kind of a drill bit, so it's going to take out a little bit more material than it should. Whereas a chaser is going to do just as it is describing. It just chases and cleans them out. It does not try to cut new threads. Now I'm feeling warm and fuzzy about all of this. For this, I'm just using the standard brake and contact cleaner from Yamaha. Now, let's get these new studs put in. And I realize that even with high temp thread locker, it's probably going to burn it up considering where it is. But the main reason I do use it is if you ever had to remove these, the thread locker, it keeps it from corroding because it's going to seal it up. Should you ever need to remove these, which you probably won't, but hey, they would come back out. Substantially easier than what we just dealt with. All right, what we're going to do next is use a ball hone, 4.5 millimeter. It's not a ream, it's just a hone. Put it in a little bit of oil, and all we're going to use it for is just to run it through a couple of times. And we're really not trying to straighten out any imperfections because I don't think there are any. I just want to make sure it's clean inside of each one of these guides. Now for this, I'm using a little bit more high performance cleaner, if you will. It's another product from Yamaha, PPC Precision Parts Cleaner. I'll be curious to see if it blows out anything on the towel. Maybe a little bit, but that could have been just the oil. But it makes me feel better knowing that it's completely clean now. Let's go ahead and get in our seats and our seals. And it does get really tight in here, so I would advise using a small magnet. Makes life a lot easier. And do put the seats in first before the seals. All right, next are the seals. And basically, they just press on. Just line it up with the pick tool and then push it down flat. You'll feel it kind of pop in place. Because you can't see it from here, but at the top of the valve guide, it has an indentation right at the top edge. And that's what this little spring is going to grab into. They don't give you a lot of room to work in here. I've got one that doesn't want to go on very smoothly, so we're going to put a little bit of oil around it to help it along. Now, the Yamaha manual says to use oil on all of them. If I can get them to go on without doing that, I usually would prefer that. That's just personal preference. Guys, there is one thing that I kind of skipped over that I forgot to mention. Before you put in the seats and of course the seals, you would need to lap your valves in. These have already been lapped in, and you can see that on the edge. I didn't request it, but they had done this at the machine shop to help me along. Now, personally, I would have rather done it myself, but if you need to know how to go through this process, go to several of our engine builds where I'll go through the process of how to lap these valves in. I think probably the best example is to go to the Raptor 700, go to that playlist and look at the head assembly, and I can walk you through how to achieve that same mark. Now we have a link to it in this card if you need to go watch that video. Now let's go ahead and add some oil inside each one of the guides. I'm going to do this from the bottom here as well as going up to the top and doing the same thing on the seal side, because I do not want that to be dry on startup. All right, now we should just be able to pop in the valves, and they'll stay in place when we bring over the vise to get them installed, the springs installed. Oh yeah, that feels good. Now I do rotate them a little bit as I'm pushing them through the seal. Now if you do as they did, the machine shop, and lap all yours at once, make sure you number them, as I've done, so you can get them in the right place. A thing of beauty. Now let's bring over that vise and get these springs and keepers installed. Some people put this in a vise and use the compressor around it. I prefer to go this direction. So to each their own, but this is a really great unit, and it comes with a couple of different optional heads that you can get to get into these tight spaces, of which this is one, and this one fits in there very easily, as you will see. So inner and outer spring. Now, line it up, bring it down. There we go. Now, a couple of different ways you can do this. You can use a magnet, but my preferred way is just a pick tool with a little bit of grease on the tip, just to hold it in place. The magnet can get a little tricky sometimes. So what you're putting together here is pretty much the same for any valve train configuration. You've got the top of the valve stem where it's got a groove cut, and your keepers are going to go into that groove, and then the retainer is going to come up because the keepers are at an angle, and that's going to lock it in place. And that's all easy to say, but hard to do in such a small space. But just be patient and work them in there one by one. One down, 11 to go. Same thing. I am one with the force, and the force is with me. Well, everybody's in place, but before we can call this done, let's go ahead and make sure they're seated. And what we're going to do is just pop it, just to make sure those keepers are in place. We're going to do each one. To do this, you can either use a socket, or in my case, I'm just using the opposite end of a 3/8 drive. But now, it's time to go ahead and go forward, get those studs mounted in there, and then get the head torqued in place. So the studs I decided to go with are manufactured by ARP, well known throughout the industry. This particular variant is the 625 aged. Now the installation process is pretty straightforward. When you're installing these in, just bottom them out finger tight. There is no torque involved. I'm going to be using red Loctite to hold them in place on each one. Not mandatory, it's just the way I prefer to do it. Finger tight, and that is it. Now once you put the red Loctite on there and bring it down finger tight, you don't want a lot of time to pass, because you want the final torque on the bolts to be done before that red Loctite sets up. Now do note the threads above your water pump is open down there, so don't force it past, otherwise it has a chance of hitting those inner gears. So on that one I'm going to go all the way down and back it up just a quarter of a turn, well, half a turn. Now the reason you're not able to use just the OEM head bolts is they're stretch bolts. These are not. The challenge with a forced induction engine is higher compression, and it's going to stretch those bolts even after they're already torqued down. And guess what's going to happen? Well, you're going to blow a head gasket. It's not if, it's when. With these, once we torque them in place, that'll be it. And also with these, you can apply a higher torque. The 625s, you can go up to 65 foot-pounds. We're going to go across the board at 60. Another advantage, not that you ever want to take advantage of this, is that these are reusable. So if you had to remove the head for whatever reason, you could reuse the studs. All right, now let's go ahead and get our dowels in place, the head gasket and We'll autograph this one for good luck too. All right. You need to be careful at this part, and if you've got anybody nearby that can help you, you're going to need a third hand to get the head lowered in. It's because it's so important to hold the timing chain and the guides dead center when you're lowering the head down. Now you can do this solo, but I wouldn't recommend it. Next, we're going to be using the assembly lubricant. ARP sends this out with all of their products. And the trick here is we want to get it on the threads, both on the stud itself and inside of the nut, but not on the washers. Now to accomplish this, I'll just be using a fairly small flat blade because it is tight. Now I know it would have been easier to get it on the studs before we put the head down, but then you run the risk of knocking it off when you're lowering the head into position. So just go ahead and do it after. Now let's go ahead and get our washers in place. All right, then we do apply a little bit of the lubrication to the bottom of the nut itself. There should be enough left when we put it on the threads. It's just on the bottom side of the washer that they don't want you to get any lubrication on. Now we're going to tighten these down in 3 stages. To make life easier, I wrote down the pattern on the head using just a permanent marker. The first pass is going to be at 15 foot-pounds, second pass 30, third pass taking it to 60. Here's where it gets a little bit scary. You ought to hear my shoulders popping. Grinding. There it is. And what we're looking for here, guys, is top dead center for cylinder number 3. And to find that, you've got these 2 marks that are parallel to each other. You bring it around, and you want to be right in between those 2 marks. Now you can verify it by just putting a screwdriver into spark plug number 3, and you can see where it reaches the top of the stroke. So that verifies that it is indeed at top dead center. What I'm doing now, guys, is I had numbered the intake and the exhaust buckets. And that's important because I want them to go back in the same slots that they were in. Now, as far as the shims go, the chances of them being the right tolerance are, well, just about 0. But we're going to go ahead and write down what each one of them is. That way, when we take our measurements, we already know we can go plug it into our formula to determine what size shim needs to go in to replace it to bring it within spec. Because these numbers will be important when we go back and set the valve lash. And yes, I realize that I'm putting this together dry. There's no oil, there's no assembly lube, because let's be honest, it's just going to make a mess because all of this is going to get taken apart and we're only going to be rotating it over 1 time. So I think it can survive that. Well, we'll give Yamaha this. So far it's 192, 190, 191. I mean, that's not much variation. That tells you, that speaks volumes right there about their tolerance levels. So far anyway. So here's our starting point. Now on the exhaust side, starting at cylinder number 1, you've got 186, 188, 189, 191, 190, and 192. Now on the intake side, you've got 190, 186, 186, 190, 190, 189. All right, guys, now that we've got our tappets in place, let's grab our camshafts and get them put in and get it timed. Now your intake cam is easily identifiable by this larger section compared to the exhaust cam. Now we want to do our intake first. You want to have, of course, this at top dead center. Lift this up, or pull that side of the chain up, and we want our cam lobes to be at split overlap. So they're both going to be pointing this way and this way for both the intake and the exhaust. And once we tighten that down with the cap, those 2 marks should be parallel. We're going to do our exhaust. It's going to be about right there. That is probably going to be it once we get everything tightened down. Now, because these teeth are so easy for it to jump around, use a couple of zip ties to hold it in place. Otherwise, you'll be chasing your tail trying to keep them in the correct location as you're tightening down the caps. When you're tightening down the main cap up front, try to bring it down level. Otherwise, it'll bind up, potentially damaging the surface, trying to get those dowels to seat properly. Now you'll notice that the other lobes are all facing up, so there shouldn't be any tension on cylinders 1 and 2. Now once we get the tensioner in place, it's going to pull the exhaust cam into position, and you're going to have your 4 marks. 1, 2, 3, 4. And then you can verify that back here, because that dot is going to be in line with this mark right here and here. Now let's go ahead and get our other caps in place. If you did not mark yours, they actually have markings on them. There's an I there and an E here, and of course the arrows are both pointing forward. Now we will be using a manually adjustable chain tensioner, but for right now we're going to go ahead and put the stock one back in, which I've reset it because we will need to set the valve lash. So we don't need to put in the manual one just yet. All right, we've got our tensioner in place. Now let's go ahead and release it. And all we're doing is reaching in and pushing on the edge of the guide to get that spring to release, and then it'll put tension on the chain. Now you never want to rotate this engine counterclockwise, because if you do, you run the risk of it jumping time. Now, as long as you keep going in a clockwise orientation, everything will be fine, but don't try to go backwards. Now that's the little bit unnerving part. At each part of your rotation, one camera or another is going to try to jump up. That's why you never want to rotate it the opposite direction. See? And that's also another reason why we're going to go with a manually adjustable tensioner. Resist the temptation to try to go backwards there. We're going to go around one more time. That's it. All right, that should be at your compression stroke, and it is, because the lobes are facing this way. But we're going to bring it around one more time. Now that's where we started. There we are. We're back at our top dead center, split overlap, intake, exhaust. So she is timed correctly. So before we can call this done, let's get in these last 3 bolts. Here, here, and then one that goes right through there. Now these last 2 are going to be 8.7 foot-pounds. Now everything's snug now. It's just hand tight right now. Let's go ahead and go across the board, working from inside out, and get them torqued to 7.2 foot-pounds. All right, guys, she is set. The timing is ready to go. Now let's get busy setting the valve clearance. Now you'll notice that I still have in our automatic chain tensioner. Now when we're done setting the clearances, we're going to swap that out to a manual one, because it'll make me feel better keeping a constant amount of tension on that chain as it's flying around. We left this engine on the split overlap on cylinder 3. Now to do the first measurement, we need to bring that around 360 at the crank. That way it's going to be at the compression stroke. So we're going to be taking our cams, which are now pointed down like this, they're going to end up being here. At that point, we can make our measurements. So we're just going to bring that mark all the way back around to top dead center. But you can watch the cams up top and you'll know about when you're there. See, that drives me crazy right there. But this is normal, believe it or not. And when you're doing this, if you miss the mark, now granted, it doesn't have to be exact because we're not setting timing, but resist the temptation to go backwards. Just don't do it because you could make it jump time. There's one mark, timing mark, and there's your top dead center. So now our cam lobes are pointing up. So now we can go into there and check clearance. This is set at piston number 3, top dead center on the compression. That's what you're after. Everything's just hand tight right now. Let's go ahead and go across the board, working from inside out, and get them torqued to 7.2 foot-pounds. Now when we measure this, we're going to be measuring from this angle right here is what you're after, and we're going to hit all 4. Let's see where we're starting off. Here's where you need to take your time and not get rushed and say, all right, this gauge fits and then this one doesn't. Take the time to get that one that just barely goes in there and has a little bit of stiction, if you will, when you're trying to remove it. If you're accurate here, when you do the equations to get whatever the shim difference is going to be, chances are you're going to be spot on. Now, if you just do this haphazardly and don't really fine tune which feeler gauge is going to fit in there the right way, chances are you're going to be off. Okay, so on cylinder number 3 on the intake side, on position number 6, there's actually no clearance. That's what we hate to have happen because I really don't have a point of reference to adjust it out. So I'm just going to put in a value of 0 for that and then adjust accordingly and see where we end up. Number 5 is very minimal. It has 0.0025 millimeters. Now on the exhaust side for 5 and 6, we have 0.279 and 0.229. Not a problem. And what we're going to do next is rotate the crank 240 degrees and then do cylinder number 1, do 240 more degrees, and then we'll do cylinder number 2. But what you'll want to do is just watch the cams because we basically want to get the lobes in the same position as we see number 3 in right now. There's 180. You can see the cam starting to come up into position. A little bit more. I think that'll do it. Let's take a look. That looks equal to me. So that's number 1 in position. Let's get those measured. So it's going to be intake 1 and 2 and exhaust 1 and 2. Now a little bit more rotating and then we'll do cylinder number 2. Let's see what we've got. Oh, please don't tell me this is going to be a 0. Another goose egg right there on number 4. It's kind of bizarre that the intake side is so tight and the exhaust is so loose. This makes me wonder if I reverse the buckets. I don't think I did. All right, out of all those measurements, the only 2 that I don't have to readjust are exhaust number 3 and exhaust number 6. Everybody else gets changed. Well, let's talk about that for a minute. In the Yamaha manual, they call for a clearance range for the intake side of 0.15 to 0.22 millimeters. And when they do the calculations in the manual, they use the 0.22 as the high side as far as the adjustment point. I don't necessarily agree with that, and I understand why they did it, because on just about every machine that you're going to put together that has OEM parts, the valves are going to start to wear, and that's going to close up the tolerance, and eventually it's not going to be very easy to start if it even runs at all. So they're running toward the high side of it. But because we're using kibble white valves in these, I don't think we need to make that drastic of adjustment. So what I've decided to do is, out of that range of 0.15 to 0.22, I'm aiming more in the middle. So for the intake side, I'm using 0.2 as my target, and on the exhaust side, it ranges from 0.21 to 0.27, so we're going to go right in the middle at 0.24. Now, the measurements on the intake side, they were all really small, if not zero in a couple of cases, and those we may have to readjust once we march closer to that 0.2 clearance. But at any rate, you take that initial measurement of 0.002, and then you subtract from that the 0.2 target. So that means I need to make a change of minus 0.198 millimeters. Now keep in mind, our initial thickness of that shim that we measured when we were putting it together was 190. In other words, 1.90 millimeters. So we need to take that 1.9 millimeters, subtract out the 0.198, and that gives you 1.701, which if you round up, you would take it to 171. But since I'm aiming for the middle, and it's 1.701, we're going to use a 170 shim. Now I've gone through and done that same mathematical gymnastics all the way down, and you can see on this chart where we're going to end up on the valve shim thickness. Now, with all that being said, let's bring around number 3 to the split overlap. So that's top dead center on compression, but we want to bring it around 360 degrees more where we're at the split overlap. And that should be getting it. Yep, that's actually it right there. So we're lined up on those marks. Our cams are facing down, the lobes and our marks are where they're supposed to be, here and here. Now we'll put in zip ties to hold the chain in place, get out our tensioner, then we can remove our caps. See, if you didn't have your zip ties in place right now, it would have jumped time, because that lobe got pushed back on that tappet. As before, there's hardly any tension on the back caps because none of the cam lobes on 1 and 2 are pressing down just yet. Take off our caps, then pull each tappet one at a time, make the necessary adjustment for that particular tappet, then put it back and go to the next. You can take them all out if you want to, but I would rather do them one at a time so I don't shift anything one way or another. All right, guys, the shims are in place. Now we just need to put the caps back on, get our tensioner reinstalled, then we can cut our zip ties loose, measure it one more time and see if there's any other adjustments that have to be made. So let's get all of these pulled down, just hand tight, snug down. You want to do it in a crisscross manner to try to bring the cams down evenly, although most of your tension is going to be on cylinder number 3, so that's the one you really need to focus on. Now once you've done that, go back and torque them to 7.2 foot-pounds, starting in the middle and working your way to the front and the back. Now let's bring it around to top dead center on our compression stroke and check number 3. So it's going to be 5 and 6. We were at 190, we went down to 170. It only measured a 0.0025. So let's see where we ended up. We're wanting a 0.2, somewhere around there. This is the one that we were completely having to guess on. We put in a 170, let's see where we ended up. 178 went in it. 0.2 will not, so I mean that's where it needs to be. Let's go over to the exhaust side. All right, number 6 we didn't mess with. We'll measure it again. Yep. Number 5. Oh, it measured 0.279 before. Now it's at 0.229. It's there. All right, guys, went through and measured, and as you can see on this chart, we are within spec all the way down, and we got lucky on those 2 0 values. Hey, sometimes lightning strikes. Next up, let's remove the OEM tensioner and put in that aftermarket manually adjustable one. Now granted, I'll be following the instructions for this particular manufacturer. There's several different manufacturers out there. If you decide to go this route, I'm going to leave it up to you to follow that manufacturer's recommended installation procedure. You will want to make sure that whatever chain tensioner you do install, that you put in a new gasket. Not collecting zip ties in our crankcase. Okay guys, we're down to the really simple stuff now. All we need to do is install the valve cover and then go ahead and pop in the spark plugs. And then we're going to call this part of the project done. Now the real trick is with this particular valve cover, they want you to Yamaha bond all of these channels as well as this section around the spark plug before you put the sealing gasket on. So we're just going to lay a thin bead of either Yamaha bond or 3 bond gray right inside these little troughs. And it doesn't take much. Everything stays in place on the webbing except this one. Now let's get her closed back up. These washers actually have seals built into them, and we're going to tighten them down to 7.2, but actually they bottom out on that edge right there, and that puts the appropriate amount of pressure onto all of our gaskets. It looks like we did okay on our bead. I put just enough and not too much. It just oozed out a little bit, and I'm good with that. Now for our plugs. Keep in mind these plugs, the threads are only, I think, 10 millimeters. So not a lot of torque here, guys. 9.4. I don't know about you, but I don't want to guess at that because they're easy to break. It'd be a shame to have to pull that head back off, wouldn't it? Well, all right, guys. On this table is an entire GYTR Yamaha turbo kit. Now there's only one part number, but as you can see, there's a whole bunch of parts under that number. Now the kit I decided to go with is actually the version 1 from GYTR. The reason I did that is, well, I kind of like the thought of the larger turbo matched with those equal length headers for this particular setup. Now the installation for version 2 for the newer models, it'll be very similar to what I'll be doing, so you should be able to follow along to get your kit installed. Now also, this kit already comes with a pre-programmed ECU. However, we have changed the compression ratio inside of the engine, so that'll have to be tweaked before we can actually get the maximum output for this particular engine. Well, Yamaha was nice enough to do a printout of every single thing we're going to need to do to accomplish this installation. It's only 12 pages, 51 different items. How tough can it be? Step 1, we need to get this radiator up front, and believe it or not, try as you might, it will not wiggle its way in. The only way you can get it back into this cavity is to pull one of the shocks and just lay them out of the way temporarily. Now these are the original shocks, however, I did upgrade the springs to a set from Eibach. Now, if you've got an older unit like I started with, you need to pay extra special attention to your suspension components and make sure they're up to the task. I had to replace most of mine, but most importantly, you want to make sure your bushings are in good shape on all your different pivot points. Also, you'll notice on this one, we have much beefier CV axles all the way around. I mean, with the kind of power that this machine is going to make, it's only as good as the strongest link in your chain, and that is one of the final links before it makes it out to the tires. So just make sure your machine is going to be up to the task when you add a turbo to it, because it's going to stress everything else probably a little bit further than it was initially designed for. So like me, you'll probably save yourself a whole lot of headache by upgrading it now instead of breaking it later and then upgrading it. Now she'll just slide straight in there-ish. All right, guys, there's 3 attachment points. Basically, you've got these 2 bolts that came with the kit. And the third point is right up here, but that gets sandwiched in your voltage regulator rectifier. And when you're remounting the shock, make sure you torque it to 47 foot-pounds. All right, guys, my next step is I have to remount the footwell so I can see where to notch out for the 2 radiator hoses to be routed through on the driver's side. The hoses are going to come through here, so we need to take out this one little section of webbing so there's enough clearance. Now, if you're watching this and you're saying, well, I don't have that particular beam on my frame, well, no, you wouldn't, because this is part of that frame strengthening kit that I mentioned in the intro. But regardless, we need to take out this section right here where the hoses can go through. These hoses are already cut the length, believe it or not. 68.5 and 112, 3/4 inch. And 44 goes to the top of your radiator, well, heat exchanger, and 43 goes down to the bottom. All right, guys, as it shows on the diagram, the longer hose, which is 44, is toward the outside of the rail. 43 is on the inside. Loops up here, goes up over the drive shaft, and actually I think that's the rear brake line. And then we're going to zip tie it up to that center section, as well as right here to hold it in place. I wouldn't zip tie it tight in place until we get it connected back at the back, and that'll give us our final lengths. All right, guys, we're going to install our water pump using the 53 and 54 nut and bolt, and it's right up under the driver's seat on that lower frame rail. So on Yamaha's diagram, it shows the long hose to the outside. I disagree. It's not the first time I've disagreed with somebody's instructions. So I'm putting the short hose on that side because that way it lines up better going to the water pump. Trick of the trade, a small spray of contact cleaner will help get these hoses on. Just be sure, because once they're on, they're not going to want to come back off. Next, we're going to take the 3/4 inch, 56 inch long hose, route it up next to that longer 110, and attach it to the water pump. Actually, you want it this way. All right, guys, I think we've got it routed correctly. There may be a few adjustments we'll have to do once the plastics start coming into focus. But for right now, let's go ahead and drop it down. And then we can put those last 2 clamps on the radiator / heat exchanger itself. Then go on to the next step. All right, guys, since we're right here, let's go ahead and connect up our wiring, even though our battery is not in place yet. But this is the cable they provide to go to it. This already has your plus and your minus, and already has a fuse built into it, so it's good to go. We're just going to leave this in place and get it connected later. All right, guys, we've got our hoses in the general area that they're going to end up. This one heads over to the pump. This one is the long one that's going all the way up front to the radiator. Now it's time to go ahead and put our turbo on our intake manifold and then get that mounted to the engine itself. Let's go ahead and get our gasket in place. Make sure it's clean. Kind of tight in here. All right, next, let's just get everything snugged down, and then we're going to use one of our Motion Pro tools to hold this wrench to get in there to those ones we can't get a torque wrench directly on. Well, honestly, there's only one that we can use just a regular extension. The other 3 will have to use this adapter to get that torqued. And that is important because each one of these need to go to 18 foot-pounds. Now we're going to make a couple of passes when we do that just to make sure, because we are compressing a metal gasket. All right, everyone's seated. Let's go around and get them torqued. We'll do the easy one first. Now the trick to using one of these is that you need to make sure that you're at 90 degrees to it. So right there, that's where it needs to be. And that distance won't matter. All right, that's all four, but let's go back and check each one to make sure they're all at the right torque. See, there it took a little bit more as we were compressing that metal gasket. All right, guys, I think we're ready to go. Let's get it put on the machine. I want to go ahead and prep these studs. I prefer to use a high temp anti-seize spray, just a little bit. Not that I'm being pessimistic, but in case we ever want to take this apart, this may make it possible. All right, next, let's get in our exhaust gaskets. Now let's bring her up into position. All right, let's go ahead and get these started. As we're working these down, you can count on having to go back and forth a few times before everything gets compressed into place and torqued down, because we want to end up with a final torque of 14 foot-pounds. And I've heard or read that after about 100 miles, we need to come back and re-torque these, probably a couple of times. But right now, let's get them all just seated, and then we'll break out the torque wrench. It amazes me how much weight is just hanging off that engine now. Like I said, we'll have to make a couple of passes because we're compressing down those gaskets. So we've got everything torqued down. Let's head over to the other side of the engine where we're going to remove one of the oil passageway plugs, and we're going to put in a flange bolt for our oil line. And don't forget your crush washer. And we've got it in there snug. Let's torque it to 8.7 foot-pounds. Now don't just guess at this, because this is a hollow bolt. And if you're wrong, you're going to snap it. All right, guys, let's get in our first oil line to that fitting that we just installed. So the 90-degree bend goes to the turbo. The 45 heads over here, because when you install the throttle bodies, it would hit the 90-degree one. Now let's get our throttle bodies on, make sure everything clears. And this is not easy, by the way. Yeah, good luck on doing that without a little bit of contact cleaner to get it to slide on. Whew. The question is, am I hitting there, or do I have a teeny bit of clearance? Good to go. Now let's get our throttle body boots tightened down, which will be more important now than ever because we're going to be under pressure. The question is, how many PSI are we going to go for? 6, 8, 12? Get it reprogrammed for 16 or 18 and have to run race fuel? Nah, we probably won't take it that far. If you went with the bigger injectors and put in the race fuel, you could get 350 horsepower, if not more, out of it. But your reliability would just have to go through the floor with that, and that's not what I want. And I'm not racing it anyway. This is just to give it a little bit more pep in its step. Next, let's get in our oil drain flange with its gasket, and it goes to the bottom of the turbo. And we're going to torque these bolts to 18 foot-pounds. Now let's get our oil drain line attached, and we just want to point it back in this direction for right now. I guess we'll go ahead and tighten that up. If we need to loosen it, we'll loosen it. All right, next let's get our 40-inch coolant line, and it heads right here. And then our 38 line goes over on the other side. All right, guys, as you can see, I am struggling in vain trying to get this one fitting to tighten up. So what we're going to do is release this arm, bring the box end of the wrench all the way up on the hose itself, then get it tightened up. Then we're going to put that arm back on very carefully and then get the circlip back in position. All right, next let's get our turbo outlet pipe along with its associated gasket on there. I'm not going to torque these yet. I'm going to address putting on the exhaust later, but for right now we're going to skip over that and head on to the next step, which is, believe it or not, to remove this timing cover or bolt, if you will, because that is where the old drain line is going to attach to the engine. Pretty creative if you ask me. So you've got the adapter, then you have this 5mm spacer, which also will seal it up, as it is made out of aluminum or aluminium. Make Jeremy happy. There. Well, I'm glad I've got the exhaust off. It'd be all in my way right now. Careful right here, don't let it cross thread on you. There's not a lot of clearance. All right, next we're going to reroute this idle air control line under the throttle bodies and then up in between the intakes for cylinder 2 and 3. Now when we get it up there, we want to actually cut off right before it goes into the turn. All right, guys, a little bit more cutting. We're going to come in and cut this, and then we're going to leave 2 straight sections, and this is what's going to attach to our 2 coolant lines that are still hanging over there. All right, so we're going to bring our 40-inch in here. And then the 38 to the top one. That should do. All right, next we just need to remove our intake air temperature off of our old air box and just transfer it over after we clean it up just a little bit. All right. Next we just need to install the nipple on our intake manifold. Now we just want to hang these on there loosely, oriented like this, so we can get to them to tighten them down. All right, let's get her popped on there. All right. Let's tighten down those clamps. Next, we need to get this little support bracket in place. Now, they'd already sent this particular nut and bolt, which is a locking type, and the one I'm going to use up top, which they did not provide, is going to have a lock washer as well. Now, if yours doesn't, you need to put some Loctite up there. Actually, this bolt will go through the oil tank, but I don't have that mounted right now. We're going to temporarily put it in place. That way I can get the rest of the plumbing done without disturbing the boots. Very good. Right, next, they want you to put the boost pressure hose to that nipple that we installed earlier. Now we're just going to attach it with a zip tie to keep pressure on it. All right, next, let's go ahead and get our first 90-degree silicone elbow on. We're going to go ahead and put on a second clamp, but that'll be tightened down later when we get our air cooler in place. All right, next, we want to remove this map sensor on the back and replace it with a 3-bar unit. On this kit, I believe that's number 20. All right, guys, we're getting ready to install the air cooler, but before we do that, I did a test fit, and this first hose that goes into it, it needs to be cut down, otherwise it pushes out too far. And it turns out that this hose is just a little too long, because if we mount it uncut, it pushes everything too far. So I've got it marked. Let me get this cut, take out about 1 inch, and then we'll start assembling it. All right, now let's see what we've got. Okay, much more like it, because your attachment points are right here. And now it lines up like it's supposed to. It just took a little bit of trimming to get it to go in there right. I think it's safe for us to go ahead and tighten these down now. Personally, it bothers me to have this much thread hanging out, but these are the bolts that they sent. Now let's get in there and tighten up a couple of clamps. In the kit, you know, she had 3 90-degree elbows. 2 of them were the same, and then you had one that goes from a 2.5 down to a 2. Of course, that goes over to the turbo side. All right, we need a little bit more distance here. Okay, once you push these on, don't push too far, because getting them to come back is not easy. Now we got it. All right. All right, guys, give me a couple of minutes just to get my oil tank remounted, because I want to be at the same point as you are in your install, because, of course, we're in the middle of doing a frame swap, and I never had installed the oil tank. But now I need to go ahead and put it in place, and then we'll modify the hoses accordingly and get that new catch can and separator installed. All right, guys, we're ready to go now. Let's go ahead and remove these 2 hoses along with the oil separator. Break that seal loose, and then she'll come off. All right, with the oil separator out of the way, we're going to use its mounting place for the cooling surge tank. Before you tighten this down, make sure you've got a little bit of clearance in between it and the intake box. All right, so we've taken away the old separator mounting place. The new separator will be mounted against this wall once that's installed. And now, let's get these protective caps cut off. Now this is going to be hose number 41, which I believe is 11 inches long, and it's a 3/4. All right, remember our hoses from so long ago that we ran from the front of the vehicle? Well, now we finally get to connect them. So 44, which was the really long one, will head to the bottom of the heat exchanger, and the other one that comes off the pump goes to the cooling surge tank. Yeah, I'm zip tying this in place, but honestly, I won't know if these are permanent until I get everything put back on. But this is generally the way you're going to want it routed. Of course, you want to keep as far away from the turbo as you can, because a lot of heat gets generated from it. So keep that particular hose as far away as it'll let you. All right, guys, you need to pay attention at this point. That brand new radiator cap that they sent, it does not go on this particular tank. It actually goes on your radiator. Now, the one that's on your radiator right now, you pull it off and put it on this tank. Now, this will get installed on the radiator once I reinstall it. So now we get to deal with the idle air control hose setup. All right, remember when we cut that one section up here? Well, now we take this 1/2 inch to 3/8 adapter and attach it to the end of this hose. Then you take hose number 60, which is 8 inches long, 1/2 inch. Attach it to the other end of the barb. Now we take the 4-inch, 1/2 inch hose and go into this T. The 5-inch to this side of the T. And then bring that back in to the 8-inch. That's where you end up like this. And we're going to add zip ties in a little bit, but let's get everything in position before we lock it in. All right, give me a minute. while I reinstall my air cutoff valve. All right, let's get this hose off our air injection valve, because that one is going to head over. That I'm reusing one of the clamps. All right, guys, the next part is to install this 135-degree arm that's going to in turn go up to the airbox through another fitting. But guess what? Looks the part is not long enough. Now I went through all kind of gyrations trying to figure that out. I even started reassembling the rest of the machine and working backwards to this to make sure I was right. And there ended up being a gap about like that. The only thing I can come up with is whatever supplier the GYTR team was using, well, they made a mistake. So what did I have to do? Ordered another one, a little bit longer, and actually cut it to fit. And you can see that's what we actually needed. So hopefully yours does not have this too short version in your kit. So with the correct length, well, let's grab a clamp and get it installed so we can finish this thing up. All right, we're going to leave the clamp a little bit loose for a few more minutes in case we have to shift anything around. But that should be it. All right, next we're going to get in our air hose, and you want to position this to where this larger barb is going toward the right side of the vehicle, and then the smaller one is facing down. Now, I also want to take note, when you're putting on these clamps, you want to make sure that the clamps end up being perpendicular and not cocked one way or the other. Otherwise, it's not going to tighten down correctly and probably loosen up over time. Now, per the instructions, hose number 62 is supposed to go from here to this T. Well, I don't know about you, but that looks like a 90-degree to me. So we had this left over from, I think it was the air purge valve on top of the engine. So what I'm going to do is cut it down and have it go in like this. Then we're going to take 63, attach it, and there will be an oil catch tank over on that side sometime soon. But once we get these at least pushed onto the barbs, we're going to go back and then put zip ties on each one of those connections to hold them in place. All right, guys, I got to give credit where credit is due. Normally, when I see a little rack or a container of zip ties like this, I go, man, that's going to be some of those El Cheapos that aren't going to last any length of time. And I make sure I'm ready with some higher end stuff to go in place of it. But upon closer inspection, believe it or not, these are on par or better than the ones that I was going to use. These are actually from Thomas & Betts. So rest assured, they're not going to let go. So you're good to go with the stock ones. Don't use the cheap stuff though. Well done, GYTR. All right, guys, before we go any further, I want to pause and swap out the injectors because this is going to have a stage 3 tune, and I decided to go with 1000cc Bosch injectors. So let me get that done real quick, and then we'll continue. You can tell this one's been sitting for a while. I think we better clean up that fuel rail. Okay, let's go. All right, for this particular setup, you do not want to use the seals that came with these particular Bosch units. They're too big, so you'll need to reorder 3 of the OEM ones to go on the Bosch injectors. All right, let's get her back on the machine. Guess you can kind of guess why I didn't want to do this after everything else was installed now, right? Right, with these particular Bosch injectors, you do have to use an adapter. So if you order these on your own, make sure you get an adapter to handle that conversion. Things get awfully tight in here with all this stuff. Now let's go ahead and get our coils in, because really once I get that adapter plate and the airbox in, all this would be really difficult to get to. Now we need to install the 1/4-inch boost pressure hose to the barb on the wastegate actuator and secure that with zip ties. All right, next let's go ahead and get that last 3-inch silicone tube on this aluminum T-fitting, if you want to call it that. We'll go ahead and get our clamps in place and put in our air box later. All right, this last one, we'll leave it pointed down to where I can get to it with an extension. All right, guys, let's get our hoses put together for this side of the radiator, which has not been mounted yet. But what you need to put together is 66, 69, 67, and then 68. And you want it to look about like this with this, I guess you call it a bleeding screw, pointed forward on the machine. So this is the way you want to set up. Then onto the water pump. I think we want to end up about right here. Now, one long zip tie about right here. So this takes care of the plumbing modifications for the turbo install. Now I just need to go back to the other side and reinstall the factory equipment for 2019. Next, let's deal with the air cleaner. Now, in the instructions, they want you to mount this plate to the frame itself, and then this holder, and then the air cleaner itself. I've elected not to do it that way because there's not a lot of working room in there. So what we're going to do is go ahead and mount the holder and the air cleaner to the bracket, and then mount the bracket to the frame. So get yours to look like this. Leave these loose so you can still rotate the housing, and we'll go ahead and get it installed. So we will be attaching it with this bolt that was also going through the air cooler, and then this other bracket down here is where you're going to feed through that 6mm nut and bolt. So let's see if we can get all of this stuff to cooperate at the same time. That is going to be it, believe it or not. So go ahead and get the silicone hose onto the intake, or the air box rather. Put a little bit of brake cleaner on it, make it slide in there a bit easier. There we go. Now we've got something. Now we can feed this through the bracket, through the air cooler, and then through the frame. Now the front part of the bracket, we're using this 10mm head bolt and then this locking nut. I think we are going to reroute one thing. The hose that's going to end up going to the catch can, we're going to bring it on top of that bracket. I think I'm liking that better. I'm not liking how this is going to rub against that edge. I think we've got enough distance to move this on the other side. So let's reroute that around. It eventually would cut through it, in my opinion. Even if I am not doing it the way Yamaha wanted it, maybe I don't want it that way. Aren't you glad I'm going through this learning curve instead of you? Now you're glad you're watching this video, aren't you? We're going to roll with that till something else proves me wrong. But I like that a lot better than what we were looking at. Now we can tighten up this back bolt. Last, let's go back and tighten up our clamp on that silicone hose. Now we had these loose, but at this point we can go ahead and tighten them down. All right, let's go ahead and get our air filter crammed in there. Well, this engine used to have a lot of room to work on it. Not anymore. All right, let's go ahead and get our air oil separator in. You're basically reusing one of your hoses from the old one and then connecting in this new one. Now, what you're going to want to do is mount this to the bulkhead. Of course, mine isn't installed yet, but it's simple. Just a couple of bolts straight through, nuts on this side, right in that general location right there. Then you also want to, of course, reattach the drain line, which was connected to your old separator. It's going to be the same size down at the bottom. All right, guys, we basically finished the installation of the turbo. Now we need to go back and put in our fluids. So we've got to put radiator fluid for the cooling surge tank. Then once we reinstall the radiator, we have to refill the engine cooling system. Then we need to prime the turbo with oil and then get the oil system refilled as well. Now, if you need help doing this, you may need to reference your service manual. All right, let's start with the cooling surge tank. We want to go ahead and fill it with coolant. Now, for me, I can't turn on the ignition, so I'm just going to use a battery to cycle the pump as I'm going through this procedure. Now, what I'm going to do is verify the pump is running, and then I'm going to check to ensure the coolant is flowing. Now, what we need to do is locate the bleeder valve on top of the radiator in the front. And we want to open this up until we start seeing coolant flow out of the bleeder itself. Close the valve, check the surge tank, and fill it again. I mean, all we're doing right now is just getting air out of the system. But if coolant does not flow, we need to unbolt the pump from the bracket, position the pump at the lowest point of the cooling circuit, and lightly shake the pump to free any trapped air. Now, chances are you're not going to have to do this, but I just want to prepare you that you could have a really stubborn air pocket that we have to release at the pump itself. So whatever you do at this point, do not open that valve up on the radiator, because you'll just have to do all of this again. And after that, you just reinstall the pump, refill the surge tank up to the radiator cap, and you're going to need at least 5 quarts of Yamaha to pull this off. So make sure you've got that on hand. Well, all right, guys, that's going to wrap up this part of the procedure, although you can tell I've got a whole lot of work to do. Now, if you need any parts for your machine, why don't you head over to Partzilla.com and we can get you taken care of. Now, if you do have any questions or comments about this particular video, leave them in the section below and I'll do my best to answer them. So, that's going to wrap this one up, and we will see you in the next video. Y'all have a great day.